So this time I'm going to start with something which looks like a Swiss cross. Okay, I'm going to start with a sheet of paper that looks like this, and I'm going to glue this side to this side. Okay, that's this arrows which I identified, and this side to this side. All right. So it still has some boundary edges, mind you, because there's some edges that I'm not gluing up, right? So it will have some boundary edges, and then I'm going to try to cut this in half in both ways. Okay, so in topology, it doesn't matter whether your lines are straight or not, right? It's sort of should be topologically connected. I cut along this central straight line and another central, so I cut along. So what's your guess? Is the resulting thing going to be connected or disconnected? Anyone? Someone else has in the chat has asked, what's the Euler number for a Mobius strip? That's a good question. I'll come to it in a little bit. Okay, so let's actually do the thing again. So I have made this cross. Okay, I'm going to glue the two sides as. So let's see. So we can do that this way. So I'm going to glue this. Oops. This edge to that, right? So there are no twists or anything this time. They're just straight across. So, okay, so that's after one of the gluings. Okay, and then if you glue, so now I'm going to glue this side to that also. So that was the other gluing. So let's do that. So this time, okay. Okay, oops. So now, once again, there's no twist or anything like that. So just glue it here. All right, okay, so. Okay, so I think, right, so you have this shape after gluing, and now, so I had drawn the red lines, you know, before I did all that on both sides of the paper, so that, and now I'm going to have to cut along, you know, both of them. Okay, so there's the two. Okay, so all right, so it's a bit more tricky to cut because there's a lot more paper around. So let me actually little snip here, and let me go to that central place and do a sort of a cross cut there so that I can come back to it. Okay, so let me now start cutting one of the loops. Okay. Okay, so cut one of the loops, and the other one now. The one. So now what you get is still connected, and in fact, it's just some kind of, you know, border of a rectangle, if you like. Okay, and so let's see what's going on just in terms of the diagram here. So let's see. So right. So right. So yeah. So what's going on? So if you cut along this, what you get 4 pieces if you want. Okay, so let me draw these 4 pieces separately first. Okay, so you get each of these pieces. Okay, I'm going to draw. Okay, once again, I'm not going to sort of worry about the lines being straight because, you know, for a topologist, that doesn't matter. Okay, so these are the 4 pieces, but remember the gluings, right? So this edge over here, now there are sort of more edges because I've cut them up. So this edge is glued to this edge. Let me draw this edge like this. So this is like this sort of for a closed arrow. This is glued to that. Then this guy is glued to this guy, and then this guy, double arrow, is glued to that guy, right? So this, after cutting, this is the same surface, right? But now I can rearrange, right? So I can, since this guy is glued to that guy, right? So I can bring this bottom guy over to the top, right? So let me try to do that. So let me try to see. This is a tool that I don't often use, but I think it will be useful here if I can make it to work. So this is a cutting tool. So I can take that and then I can place it here, right? So the arrows match up, right? So those arrows match up, and so this is the same surface, right? I've just, the 2 things that were identified, I just represent them as identified. So now this guy disappears, right? So we have already sort of represented these are glued by sort of actually gluing them, and similarly if we do the sort of the other ones, so remember that. So let me sort of mark it again. So this guy, this side is identified with this side. Look at the arrows, right? So the double filled arrow, solid arrows glued to this. So if you place this bottom guy up there, so let's try to do that again. Okay, oops. It's something I'm not quite used to. Okay, right. So now if I place them here, so then I get this, and then finally I can place this here, and you can see that it sort of matches with, oops, let me sort of try to do it again. It matches with the 2 glued up things there and there. Maybe it's sort of, since I wasn't accurate about measurements and all, so these, once after gluing, these are identifying, these are kind of disappear, right? So this is sort of this, and then you have this and this. So you get exactly this square that we're, or this, you know, so the square with a hole cut out that we were talking about. Okay, so this, if you cut along these red edges, cut along red lines, then you get something which is connected and which looks like this. Okay, there's another, you know, thing that you could do. Okay, and this one I'll leave. I'll sort of have a video. I'll send out a video link to do that. So another thing that you could do, if you take the same cross, okay, and then so it's the same kind of thing to start off with. And this time, you glue it by half twists, like you did in a Mobius strip. So this edge is glued with this way, and then this edge is glued with this in this way. All right, and then you cut along the red lines. Okay, okay. So again, once again, the straight or something doesn't matter. You just cut them in half. Okay, and this time, you know, sort of it turns out that when you do it in Euclidean space, it depends on how you, so which direction you do the half twist. Okay, so it's sort of it's an interesting thing, and when you cut it in half, then there is something that's interesting that happens. Okay, so I'll send out a video of this experiment. Somebody else is doing it. There's a wonderful YouTube channel called Number File. Okay, which is sort of very interesting mathematical mathematics and various mathematical things. And so this is a number file video that I'll send out a link of, and which does this experiment, which is sort of this funny kind of glued up thing, and then cutting it in half and seeing what happens. Okay. Question: what happens when you cut along red lines? And sort of answer, so wait for the video link, or you can try it yourselves, of course. Okay, so so this is these are some of this paper experiments that I wanted to mention. And so so what happens? So let me say, so another sort of question that might arise. So what happens when you glue two Mobius strips along the boundary edge, along their boundary edge? Okay, this is something that's difficult to do in real life, because this paper is not a good enough thing. So you have two Mobius strips. Let's say you have two. So each of them have a boundary edge, right? So a single boundary edge. Remember, there is a connected boundary edge. Now I want to sew these two along these boundary edges. Okay, and so now you'll get something. You'll get a surface without any boundary, right? Because I mean, this boundary edge is sort of glued up with this boundary edge. So now there's no edge at all, right? And so you get some surface. Can somebody tell me? Does somebody know what surface you get?